Hi guys, it's Mr. My Money again. Welcome to Simplified RSA, the guys who makes it look easy. Today I have a tip for, since we are still in physics, right? And I've mentioned that, okay, the topic that we are still under at the moment is still equations of motions. And we have our equations of motions. This is how our equations of motions looks like, right? So we have our equations of motions here. Now, these equations of motions, they involve five variables, like five things to calculate. Five things that they have to be given. Either this one is known, either that one is unknown, but then we call them variables, just like when we are solving for x in mathematics, which is the unknown variable. So these equations involve five variables. These are the variables. Let's look at the variables here. So just like I said, these equations of motions involved this number of variables. We have the initial velocity, we have the change in distance, we have the acceleration, we have the time, and we have the final velocity. For cases where you have to apply these equations of motions, it's always advisable, right, to always show on your data what value do you have, what value do you not have, so you can know what is the unknown, or rather, so you can know what are you calculating. So this is my advice to you. My advice to you is, now you have read the paragraph of the question, now you understand which equation you're going to use. It's advisable to always work around your equation first before you can substitute. Whatever variable you are meant to calculate, at least try to put it in the form of the subject formula, and then you substitute after. Trust me, if you do it like that, always, if the question came out of 4 and then probably you didn't substitute right, you can at least get 2 or 3 marks, and then you're just going to get the wrong substitution or the wrong final answer, something like that. I always joke around by saying a student can get a good marks in physics even though they didn't bring a calculator into the exam. That's what I mean. Like, you play around with your equation, and then when you get to what they want, and then you substitute from then, and then you get your final answer. So you only have 2 or 3 steps that involve numbers. The other top steps is just you bragging and playing around with your mathematics. But then still, me saying this, it might not make sense. Let me write it down and show you what I mean from our given equations of motions, right? So think of it like this. For scenario number 1, suppose I'm given this in my data. So suppose the initial velocity is 2 meters per second. The change in the change in distance, I don't know. My acceleration is 3 meters per second squared. I don't know the time, but then the final velocity was given to be 5, right? Which is 5 meters per second. If I apply my equations, the first equation I'm going to choose, if I decide to calculate the change in distance first, obviously I don't know the time, so I have Vf squared is equals to V initial squared plus 2a change in x, right? All I'm saying here is because I can go straight here and substitute. My Vf is 5 meters. It's equals to my V initial is 2 meters. So I can substitute then the 5 meters per second, 2 meters per second plus 2, and then my acceleration is 3. I get that, and then change in x, and then I solve for change in x. Now, what I'm trying to install in our minds right now is that before you even substitute, first write the entire equation. First, represent the equation in terms of changing x before you can substitute all your values. So you play around with your maths to claim your marks, right? So if I take this to the other side of the equal sign, I'll have Vf squared minus Vu squared is equals to 2a change in x, right? But then I want to calculate change in x because that's what it's unknown here. And then I'm going to divide by 2a here, and then I'm going to divide by 2a here. 2a for 2 acceleration, because I only want to have change in x alone because there's a multiplication sign here. Therefore, this will cancel that. Therefore, my change in x, which is the distance, is going to be Vf squared minus Vu squared all over 2a. And then from here, I can substitute my values. So I know that my Vf is 5 meters per second squared minus my initial velocity is 2 meters per second squared all over 2. My acceleration is going to be 3 meters per second squared as given. Therefore, this will give me the actual distance. So then this will give us 7 over 2. 7 over 2 is actually 3.5 meters. So that means the distance that we don't know here it would have been 3.5 meters. So even if you could have substituted wrong here, but then given that this question could have been 4 marks, you could have got at least 1 mark here, 2 marks there, just for playing around with your maths, and then you'd be wrong from then. So you've gotten something to accumulate towards your final mark. So that is what I'm saying. Don't substitute on the first given equation and then you look for the unknown variable. First, play around with your equation the way it is, and then you put whatever variable you want to calculate or whatever variable that is determined to be answered in that question. Put it in the form of the subject of the formula, and then you can substitute from there. What if we had to calculate t again on this one? Let's see if we had to calculate t, and then because the t is still unknown. So again, if you were to calculate t, probably you would select the equation Vf is equals to Vu plus At, right? And then here we want to calculate the time t, unknown, supposedly. And then here, before I calculate t, I'll make t subject of the formula. And then if I take the Vi to the other side, I'll have Vf minus Vi is equals to At. And then I divide by A because I want to calculate t. This cancels that. Therefore, t will be Vf minus Vi all over your given acceleration. And then you substitute from here, like I say. If you substitute from here, your Vf is 5 meters per second minus 2 meters per second all over 3 meters per second squared, because it's the acceleration. Therefore, if we punch this on a calculator, our final answer will be 5 minus 2, which is 3. 3 divided by 3 is 1 second. So it took 1 second for the whole thing to happen. I know it's not accurate. This equation is just... So at this point, I just wanted everyone to understand the concept of how to answer these questions. Not just in physics, it's always advisable to play around with your equations and then make the variable subject of the formula the one that you want to calculate. It makes it easier. Like it shows understanding even to the person who's marking your script. But then for now, since this data was just imaginary, let's get a question that is similar to something we'd get on an assignment or in an exam or something like that for high school students. A racing car is traveling north. It accelerates uniformly, covering a distance of 75 meters in 10 seconds. If it has an initial velocity of 10 meters per second, they want us to find its acceleration, right? So now let's show on our data, what do we have? So here we have a racing car traveling north. It accelerates uniformly, covering a distance of 725 meters. So it covers a distance of 725 meters. In 10 seconds. It covers the distance of 75 meters in 10 seconds. And then its initial velocity was 10 meters per second. Its initial velocity was 10 meters per second, like that. And then they want us to find the acceleration. From here, obviously, my choice of equation is going to be this one. Here, my choice of equation is going to be this one because it has the change in distance, it has the initial velocity, it has also the time that was given. The only variables that we don't know here is our acceleration. So before I substitute everything, because now I want to know the acceleration, before I substitute everything, I'm going to first make A subject of the formula. To make A subject of the formula, I'm going to put everything that is not involving A to the other side. So here I will have change in X. When I take V, initial velocity multiplied by T to the other side, I'll get minus VIT. It's equals to 1 over 2 AT squared. Here I have 1 over 2 AT squared, meaning I can cross multiply because everything is over 1, right? If I cross multiply here, I'll have 2 into change in X minus VIT is equals to AT squared. But then I'm looking for A. I want to solve A because that's what I want to show, the unknown A. So I'm going to divide by T squared both sides to have A being subject of the formula. So if I divide by T squared both sides, I'm left with A is equals to 2 change in X minus VIT all over T squared. And then I say I can substitute from here. So I'll have 2 is 2725 minus initial velocity is 10 meters per second times 10 given seconds. So it's 10 meters per second times 10 seconds for the time. And then all this divided by 10 squared because t is 10. And then you work this out on your calculator. If you work this out on your calculator, your answer is going to be if you work this out on your calculator, your answer will be 12.5 meters per second squared. So it's a positive answer, meaning it is accelerating north at 7.5 meters per second squared. But that's not the point for now. The point for now, what I wanted to install in our heads is that before you substitute at the given equation, or rather now, you're given a question, you've made a selection of the choice of an equation you're going to use to solve the question, because the question would probably come in the form of a word problem. And then what you do is, after you have your equation, now you have to calculate the unknown variable. It's advisable to first play around with your formula, put the variable that you want to calculate in the form of the subject of the formula, and then you substitute after, just to claim marks for the cases where your substitution happens to be wrong. That's it for now. On the next video, we're going to try this question here, which is similar to something that we get on a question paper. Here's the question here. We're going to do it on the next question. For now, this is what I wanted to say for now. I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy. Please subscribe on our YouTube channel. Please follow us on Facebook, follow us on Instagram, follow us on TikTok. Also, forget and like our videos. Yeah, man. Then until we do the next